Hello again everybody, Spanker here, and we are at the second video of this Arduino. So we're not going to mess about talking about things again, we're going to get right into it. So what you need to do, you need to go to arduino.cc, go to software, download the latest version for your PC. I think it's for Windows, it's about a 90 meg download. Install it and then open the Arduino icon, and it'll look something like this when it comes on. So this is maximized. So the first things we need to do is, this is the blank one, we're ready to start coding. First thing we need to do is go to Tools and then select the board that you're using. So I'm using a Uno, a clone of Uno. So I've selected that. The port, if you can select it, it will be, once you've installed the drivers, it will come up with a port. I think mine was COM port 4, and it's ready to, there, you're ready to go. So if I just flip back to this, I've got this USB cable. Now for this first application it will be enough power to get this doing what we want to do. So I'll just plug that in. We get a little bit of a flash. LEDs are flashing, and that's it. You might not be able to see because that's a very bright LED for that camera. Basically what we've got on there, we've got that LED that my finger isn't covering is actually a red LED. Let me just turn this light off a little bit, see if I... Well, there's two LEDs. There's one that we can see flashing about once every, well, I can tell you exactly how long it's flashing. It's flashing once every 1000 milliseconds. So what this board is doing now, it's running a program, and the program is telling it to turn this LED on every 1000 milliseconds, turn it on for 1000 milliseconds, turn it off, wait. That's all it's doing. So that code is in the examples here. It's called Blink. So if you go to File, Examples, Basics, and go to Blink, it'll pull up this window here, and let's have a look at this code. So if you know roughly about code, this bit here, this backslash at the top left with the star, means everything between the backslash and the star, sorry, forward slash and the star and the forward slash is what they call commented out. This means the microcontroller will absolutely ignore everything in there, so you can put what you want on here. This is just for making notes within your programs. It's a good habit to get into. 2 forward slashes like that is again commented out, it'll ignore that. And it's just telling us what it does. The setup function runs once when you press reset or power the board. So it does a setup, initialize, and then the next one is, that's commented out, this is initializing the digital pin LED built in as an output. So this is pin mode, LED built in, output, and then the loop function runs over and over again forever. So it's a void loop, and then digital write, LED built in, I, delay 1000, LED built in, low, delay 1000. And because it's a loop, once it's done that instruction, it goes back to the top of that instruction and does it again, and does it again, and does it again until, well, forever, until it loses power or something blows up. So let's have a look what this is doing. It's, the first part is saying pin mode, LED built in. So the one that was flashing is the built-in LED, and it's telling us to put that as an output. It's telling us that it it to be called the LED built in is an output. Digital write means write out to that output. So digital write, LED built in, turn it to I. And because it's a digital output, it's got two states. It's, you know, it's on or off. So I means it provides a voltage out on that pin. Low means it doesn't provide a voltage. So what it does is turns it to I. So it's literally putting however many volts out through that pin. It delays for 1000, which is in milliseconds, so it's wait for a second. And then after 1 second, it tells it to go off. So make the voltage low, it's telling you here, wait for a second. And then it goes back again. So in effect, what we get is this light flashing. Now I know, because I've worked with Arduinos quite a bit, that LED out is also the same output as pin number 13 on the board. So what we're going to do, we're going to do something here with the breadboard. I'll get it right in there. We're going to get, you can do this, as long as you get it right, you can do this while it's still connected. I'm not going to, I'm going to turn it off though. Let's just power it down. We're going to find pin 13, which is this one, and plug in pin 13 into there. And we're going to drop it onto the breadboard. There. We've got a resistor. I think it's a 220. I'll turn the lights on, that might be a bit better. I think it's 220. And on that same track that the output's on, I'm going to put one leg of the resistor in. We're going to go into a slot which is 2 up. And then we've got another LED here. LEDs, the legs tell you the polarity. Positive is a longer leg. So on the same track as that second leg of the resistor, if I just disconnect that and pull that up, we're going to pop in, same track as this leg, we're going to pop in the LED and put it into the next track as well. So the LED then goes in there. And then, so that goes back to pin 13. Then we follow that track of that leg of the second leg, the negative leg. Plug another cable in there, and we're going to find somewhere on the board a ground. So there's a ground here, right next to pin 13, there's a ground. There's 2 grounds over here. I'm just going to bob it into that one next to pin 13. So because pin 13 is the same output as the built-in LED, every second it's going to send power down that line, through that resistor, through that LED, back up and back to ground. So it makes a circuit. So when we boot this back up again, this LED should start flashing in the exact same time as that one. So let's have a look if that works. So it's doing its initialization, LED's flashing, and then every second that LED comes on. There we go. So let's go back to our code here and let's make some modifications. So it's digital write and it's delayed for 1000 milliseconds. What I'm going to do, I'm going to change that to 2000 milliseconds. So it's going to come on, it's going to stay on for 2 seconds, and then it's going to go off. But then I'll only want it to wait for 100 milliseconds. So we're changing what we want that LED to do. What I would then do now is up here, top left hand corner, upload. That's compiling the sketch, it's giving us some information at the bottom of the screen here which you can't see because for some stupid reason I've got the setting wrong. Let me it's because my screen resolution is 1440p and the capture is at 1080p. So we can see the full screen now. So we've got that going to 2000. We click upload. We've got some stuff down here telling us how much memory it's using, and it says here done uploading. So let's have a look back at what's happening now. So it stays on for 2 seconds, flicks off for 100 milliseconds and then comes back on. Interesting. So let's change it again. Let's put this to 100 milliseconds. So it's going to come on 100 milliseconds and then off. Upload, and straight away staying on for a tenth of a second and going off. And both LEDs are doing that, and they do it in perfectly synchronized. Let's go back to this screen again. What we could do is tell it to do 1000. I'm just going to copy that there. After this, we're just going to enter. I'm going to delete that comment out. We don't need it because it's not going to be relevant. Paste that back in, so it's going to come on for 1000 milliseconds, go off for 1000 milliseconds. We're going to turn it back on now for delay 500. And then we're going to do it low again, so I'll just copy and paste that. Low for delay 500. Oh, I can't even spell delay. So it's going to come on for a second, go off for a second, come on for half a second, go off for half a second, and then loop back. So let's upload that. That's uploading, that's done uploading. And let's have a look what's happening. On a second, off a second, on half a second, off half a second, and away we go. So, what's an application of this? I don't know. You could have I suppose you could program an automatic text to Morse code Arduino box where you could type in text, send it to have it decipher into Morse code and send it to an LED. I don't know, there's lots of applications. Indicator lighting, obviously different pulses will mean different things, and that's just from that one pin. We can actually change this to different pins if we want. So for instance, now if you shouldn't do it live, but if I put this into pin 8, nothing happens because the program hasn't been given any instruction for pin 8. It's only got instruction for the built-in chip, which just happens to be linked to pin 13. The brightness of this LED is dependent on obviously the voltage. In fact, while we're here, let's measure some things. Okay. Can't get that on. So it's, we need to change something here. Let's just delete all that. Let's just try deleting all that. We'll hit the delete button. Sorry, I didn't switch my screen. So all I've got now is digital right, bulletin eye. Let's just upload that. So when we go back to this, basically I've just told it to permanently keep that LED eye, because I couldn't measure voltage when it's fluctuating about, could I? So we've got 2.6 volts across there. .9 across the resistor. So that LED, it may look it on the camera, but it's not super bright. Why don't we just try and get into this little box of tricks? Let's put a couple of different LEDs and see what happens when we put a couple of different LEDs on there. So we have a little box of tricks here. Let's try. That's a small LED. Why don't we try one of these bigger ones? So I'm just going to pop that out, pop that in. It's not very bright, but don't worry. What about a? Obviously, I've probably got too big a resistor in there. That one, green. That's not a bad one. It does look really bright on the camera, but it's not that bright when I'm sat here looking at it. What's these ones? This looks, I don't know what this one is. Let's have a look. That might be IR. I think it might be. What's that one? Stick that one in. Oh, we've got a nice little blue one there. That does look bright on the camera. That is quite bright. So there we have it. That is our first little bit of working, bit of doing things. Oh, I've got a WhatsApp module here. This module, 3 colour LED with a resistor. So what if I just stuck that? Oh, it's got a resistor. Let's just stick that in, which is ground. End pin. Let's see if this works. Ground, and then I don't know what I think I might have blown that at a different point in time, because these have built-in resistors on them, so you can just, it might not be high enough. Pin 13. I might not have high enough power to get any thing through, or I might have blown it. That's why it's in the little dumping bin. Not to worry. Anyway, that is it for this video. Thank you for watching, and I will speak to you later. Spanker out.